In event driven architecture, everything works or acts or triggers based on events that are published by publishers. We will discuss that what is a publisher, what is a subscriber, and what is a broker. So uh, let let me tell you how the publisher, broker, and subscriber communicate with each other. So let us draw a diagram. This is publisher. Now I have drawn a broker, and next we have a subscriber. Hmm. Okay, so let me draw it small. So we have a subscriber. So let me write here pub, pub for publisher, broke for broker, and we have sub for subscriber, right? So we have publisher, we have broker, and we have subscriber. Then how this architecture works, publisher publishes a message and it releases it to the broker. Now that message is stored in a queue. That queue consists of the messages or events or topics, whatever you want to call it. Then that topics are stored in that queue. Then the subscriber subscribes to that queue, and there are multiple subscribers subscribing to the multiple queues, but the subscriber which subscribe to that particular queue will will receive that task or event and trigger something or process something that is defined in it, right? In this way this whole architecture works. Publisher published a message. Okay, publisher publishes a message. The broker saved that message and transfer it to the desired or correct subscriber, and subscriber perform its task based on that event. This is a simple concept of pub sub model. We call this model as a pub sub model. All right. So now let me discuss in this model in detail. This was a basic working, a fundamental working of a pub sub model. I have explained it in very simple language. Now let us discuss it in detail. So there are three publishers. For example, okay, here are three publishers, and we have subscribers as well, and we have one event broker. This event broker could be Apache Kafka or RabbitMQ. These are two popular message brokers. Then we have taken the example of a e-commerce service where there is a service, publisher service called order service, which will emit a event like order placed, right? It will emit a event called order placed. Then that event will get into broker. Then the subscribers like notification, inventory, and shipment that subscribe to that particular queue will trigger or react to that event, right? In this way, like notification service will react to that event. Okay, inventory service will react to that event, and shipment service will react to that event in that queue, because all these services, notification, inventory, and shipment, are subscribed to that queue, right? So let us understand the working first. Order service published a message named order is placed. So order is placed will get into that queue. Now what happened? The order is placed is saved into this queue. Okay. Now this notification service this notification service got triggered, and it processed the task, and it sent the notification that hey, order is placed to the customer, right? The notification is sent to the customer. Next you have inventory service. Okay, let me next you have inventory service. Okay, this inventory service is responsible for uh, decreasing the number of items in the inventory and from database as well. Okay, it is decreasing the number of items from database and everything, so that there should be consistency everywhere. Now you have a shipment service. So just when the order is placed, shipment service is responsible for taking all the information of that order and of that customer and deliver that order to that customer. So all these three tasks are performed based on an event released by order service or emits by order service. Okay, we use word here listen, that services are listening to the broker and publisher emits the event. So this is the whole terminology of this architecture. So in this way, the uh, the architecture works overall. Let us discuss how you implement this architecture in real life. So let's talk about the cloud native applications. You have a S3 bucket in AWS. Then let's say you have a Lambda function, AWS Lambda function, and you have linked this Lambda function with your S3 buckets, right? So you have linked this Lambda function with your S3 bucket. Whenever you push any object like image or file in S3 bucket, this Lambda function right here will perform some task like resizing of that file or that image, or changing the ratio of that image. For example, there could be some task that should be performed. So this Lambda function will run some task whenever you insert any object in this bucket. So in this way you implement a event driven architecture in cloud. Okay, so we have discussed how we can implement event driven architecture, the basic workflow of event driven architecture. We have discussed the examples of broker like Apache Kafka and RabbitMQ. Apache Kafka is really popular and RabbitMQ is also, they are equally popular, I'll say. So you can, if you want to choose any of them, you can choose any of them, but Apache Kafka has a edge, I'll say. So both are same, whatever to choose whatever you want. Advantages. Then let when we talk about advantages, you have flexibility in this architecture. Okay, so what I mean by flexibility, flexibility means you can add and many services as you want. So as many services means there are three services, and if you want to add a payment service in this architecture, so it is really easy to add a payment service in this event driven architecture. Next thing is flexibility, because adding a services is easy because these services are not listening to each other. Second thing, these services are independent of each other. Third thing, these services are not communicating with each other. So they are completely independent of each other. They are only reacting to the events that they have subscribed to. So this thing you have to understand. First thing, we have discussed that it is flexible. You can add as much as services you want. Second thing, second thing is scalability. Scalability means you can increase the number of services or servers of that services if that service is receiving larger traffic. For example, inventory service or shipment service. Let's say shipment service is receiving larger traffic from customers. Then you can simply increase the server of shipment service. Third thing is loose coupling. Just like I have said earlier, the services are loosely coupled. It means that they are independent of each other, right? They are independent of each other. They are not communicating with each other. They are only reacting to the events, or they are only triggering to the events. It's as simple as that. Okay, in software development, we only focus or mainly focus on loose coupling. We are not focused on tight coupling. Tight coupling means everything is dependent on each other. If one thing crashes, other thing will get crashed automatically because it was highly dependent on that thing. So, loose coupling will reduce the chances of crashing of that application. Loose coupling which will decrease the chances of having bug in that application. So we discussed three things. Then we have fault isolation. So services are not dependent on each other. If one service is down, for example, notification service is down, your inventory service and your shipment service is live, because it simply means that your whole application is not down. Your search service will work. Like you can search the products you want. Only the notification service will not work temporarily, but all the services will be live in this architecture. Same advantage we will get in microservices architecture as well, but we have that same advantage here as well. And uh, we have fault isolation, then real time processing. Just like I've discussed, order is placed, order is saved into broker, then notification service run its task based on event. I mean, it triggers its task. Then all these things happens in real time. So you we use this architecture highly in real time applications. Then we have asynchronous flow. Firstly, what is mean by asynchronous? Asynchronous means two things are performing their task independently of each other at the same time, or they are not getting affected by each other even though they are in the same environment. Like, it simply means that they are independent of each other and performing their task at the same time. So notification service is performing their task at the same time. At the same time, inventory service is also performing its task. At the same time, shipment service is also performing its task. It means these services are asynchronous of each other, and and you are reducing your cloud bills with this asynchronous nature, because you are paying. For example, you are using AWS Lambda, so you are paying for the execution time. You're not paying for using that AWS Lambda function. You are paying for the time. For example, that Lambda function took 5 seconds for execution. It means you are paying for that 5 second of time. So your function should be highly optimized. And if there is a parallel functioning, it will be a cherry on the cake. So I'll say it would be a cherry on the cake. Then we have discussed advantages. Let us discuss disadvantages. Disadvantages have complex debugging. So let us discuss two of these disadvantages combinedly. So complex debugging means, mm, for example, there is a issue in your inventory service, right? Let me take it to the inventory service. For example, you have issue in your inventory service, and you have to find the cause of that issue. So now you have to go through all the events that caused that triggered that inventory service. So this is a small example, but in real life applications, in the PubSub model, there are multiple events triggering to a particular event. So you have to go through that all the events, and finding the cause in this event driven architecture is really hard, because you have to study all these events, then you have to analyze the working of that events, and then if possible, then you are able to find that cause. So it is really hard to find the cause. Next thing next thing we have infrastructure overhead. Infrastructure overhead means, in earlier architectures like monolithic and microservices, we don't have any extra component. In microservices, you will say that we have service registry, but service registry is not a extra component, I'll say. Service registry just store the information of the services, but and it is not compulsory to add service registry. We add that service registry for security. Here, the event broker is compulsory component, and it cause a extra overhead, and it's like a heart of this whole architecture. So broker added at some extra cost, and it increases the complexity as well. And it causes a single point of failure. It means if broker is down, everything is down. So broker is a single point of failure. If broker get hacked, everything will be everything will be destroyed. So broker plays a really important role. Then you can add here single point of failure of broker as well in disadvantages. Then you have testing challenges, testing all these subscribers, plus testing these publishers with this event driven architecture. Like, if you want to test the inventory, you have to run all these triggers that triggering this inventory to test the whole workflow. So this architecture is really complicated for testing, and you have to implement the DevOps pipelines for all the services. This also became a really hard task. So we can have testing in disadvantages. Then tracing is also hard. Just like I said earlier, in debugging, tracing the cause of the issue. For that, you have to go through loggings of all the services, like logs of all the services, and you have to go through the events of all the services. Then if you find that issue that caused the service, it is really hard to find that cause, because you have to go through all these events, and understanding the working of that events is not possible. It is good for a smaller projects, but at the larger level, it it cause some issues. Then we have discussed some disadvantages. Then we have to discuss some features. Here it is written that services don't communicate with each other, right? Si- what I mean to say is services are reacting or triggering based on events caused by event broker or the services before that services. Like, it is not necessary that a service is dependent on broker only. A service can be dependent on another service as well. Here in this architecture, services can emit the events as well. Services also emits their own events as well, and services can listen to other services. It doesn't mean that services are communicating. Communication through REST APIs and gRPC are different things. Here services are only listening to each other. Like, for example, uh, payment service is listening to the inventory service, right? Or payment service is listening to the shipment service, or shipment service is listening to the payment service. It would be a great example. Shipment service is listening to the payment service. So when the payment is successful, shipment is ready to deliver it to customer. uh, okay, so features: loose coupling. Loose coupling means services are not dependent of each other. Then I have discussed loose coupling earlier as well. Then add services. Uh, the architecture is flexible. It means you can add as many as services as you want, and you can link that services to the particular other services or broker, and your service is ready to execute. Then you have perform tasks on event. That is the specialty of event driven architecture. Each service perform its own task based on events. So services are not dependent on each other. Services are dependent on events only. So this will reduce cra- the crashing of that application or failure of that application. So in this way, we have discussed the workflow of the workflow of event-driven architecture, and how we implement that architecture in real life. Types of brokers like Apache Kafka and RabbitMQ. These are two great brokers. Then we have features. We have discussed features, advantages, disadvantages, and how a pub sub model works